my name's Akanksha Malik and I'm from Melbourne.
Excellent, Sami. It's Bal here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉。
England by Nederland.
I'm Arafat Yassir from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi,
I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Mehdi Ali Daoud from Ghana.
Hi, I'm Ana Kamana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
Hi. Hi.
Hi.
Hi.
Another episode of AI Talks Live. And today we have another speaker just as every week, and we are welcoming Bruno. Hi Bruno, how are you?
Hello everyone, hello from the not so sunny today Canada. We are enjoying the summer. We have a very short summer, so we take the best of it. But yeah, it's a pleasure to be here. Thanks Amy, hey, thanks everyone. And hey, I'm happy to share some lesson learned and stuff today.
Cool. Well, Bruno, first of all, I want to thank you to do this session last minute because Darren was not able last minute. So thank you very much for falling in for him. We really appreciate this. Maybe it's nice to learn also that we're also streaming now live on Microsoft Learn TV. So it's an extra platform where you can watch these episodes. But of course, Bruno, just tell you something about yourself. Who are you for those who do not know you yet?
So yes, probably noticed the accent, live in Canada, not Canadian. I was born and raised in Argentina a long time ago. I lived in Spain 11 years. I moved to Canada 4 or 5 years ago. I think it's 4.5. And I've been an MVP for over 10 years in different categories. In the last couple of years, I've been an MVP in the artificial intelligence category. And I am not a machine learning expert, a very smart data scientist. I just like to play around with technology. I like to use tools and try something new to solve problems. And that's my key thing, that try to solve problems using technology. And lucky for us, in the last 5 or 10 years, everything ML related, artificial intelligence related, is becoming very accessible. It's at the place that we can play and learn and use it. So, hey, that's an amazing spot for me to try new things, to learn and use it. So, hey, I am very, very happy. I'm sorry if you search my name in the internet and you find pictures of myself with customs or whatever. I always do this for a good reason. But, hey, it's a pleasure to be here, and I'm always open to share whatever I am doing. I hope it's helpful for someone else.
Yeah, we see just AI on itself. It's something that is really glowing up the world with so many different kinds of projects, and it's not only for professional data sciences anymore. Just as a junior developer, you can build AI applications already, and that's really cool. So Bruno, today you're going to talk about some project you did with a drone. Small introduction to it.
Yeah, so long story short is back on December, I have a colleague here, Daniel, and he's also an MVP, and he told me about this drone. Let me share my screen so you can start to look.
Okay, let's go to your screen.
Of the drone. So there it is. That's my screen. That's the usual, what we are going to see, my data. You're going to find this later. I'm going to go very fast here. I always start, basically, sorry about the crappy animations, crappy demos. This is just for fun. Big disclaimer here, do not use this in production, or maybe yes, but it's just testing and learn. So sorry about that. And the stuff that we're going to see very fast here, mostly Python code, community services, a couple of concepts around networking, Docker, and a couple of things. Nothing very, very deep, but the important part is, as I always said, second warning here, this is my code. This is myself giving advice on that code. I love this meme because this is basically what I am doing. So, hey, I will share everything later, but this is what we have right now. This is basically the code that I'm going to share. And it's also part of this. You asked me how this all starts. It all started when Daniel asked me a couple of months ago, I think it was from January, December, that, hey, have you played with this drone? Do you know this drone? I've been playing with drones for a long time. And what I feel always is that if you want to do something with, I don't know, if you want to program a drone, do some program a drone using your own language or whatever, the SDKs are kind of expensive. The drones who support this are also expensive, so they are not open to this. But then I get to this one. This is $100. It's depending on the day. You can have it for 75 or 60 or 150. So it's not very expensive. It's not $1,000 drone, and it's also have some very cool features if you think of the drone per se. Of course, because this is a toy, it has a very small battery, so the battery is going to give you 10 minutes of flying. You can buy extra batteries. I get an amazing combo of batteries and propellers and other stuff for, I think it was $10, and I have 2 extra batteries and a couple of propellers. But what I also like is that it has 2 Wi-Fi antennas, so it gives you a decent connection range. You can connect to the drone up to 25 meters. I think that's the better who work for me. And it has a nice camera, a 720p camera, which is not the best quality. But again, to play around, to learn how to use it, it's very, very good. And of course, it has some smart features. When the battery is down, it's going to automatically land. It's going to basically save protection. It's automatically stabilize itself. It has a couple of cool features. But when I start to play around with the drone, when I start to investigate the drone, I found that they have the capabilities in the page to do programming the drone. And they use Scratch. And Scratch is this block language. It's mostly for kids, where you are drag and dropping blocks, and you start to connect actions, and you can do loops, you can do conditions, and you can do a lot of things. And I was starting to think to myself, oh my God, if you can do this with Scratch, there probably is an SDK in the back where you can interact with the SDK. So that's when I started to try to figure out if I can get access to an SDK and I can start to play around. I couldn't find an SDK. I couldn't find anything official in the main page of the drone, but somewhere there, deep in the manufacturer of the drone, I found a PDF which basically describes how you can connect and use the drone. And it works like this. Basically, the drone is going to give you a Wi-Fi hotspot, so you can connect to the drone as a wireless network. Once you are connected to the drone is always open 3 sockets using UDP, not the best protocol, but this is what it is. And we are going to, one of the sockets is to receive information, so you can send commands. The other is to publish the drone information, so you can get information from these other sockets to check the drone temperature, or I don't know, altitude or time of flight, other values. And the third one is for the camera. And I will get to the camera in a specific topic, which is the one. And then in the same document, you have the commands that you can send to the drone. So you can send to the drone, take off, and the drone will start to fly. Or you can send to the drone, land, and the drone will land. Again, this is UDP. So you send a command and you don't know if the command is there or not. That's the amazing stuff in UDP. This is a very old UDP joke. I think I learned this joke back in my university days, so 20 years ago or more. I couldn't find the source, but this is UDP. I was hoping for a strong handshake TCP connection. This is UDP. We are going to aim for the best, but this is how it works. And in order to get this, I play around, I make some advances. I'm going to show you a couple of cool things I think that we can do with the drone. But this is how I have the drone set up today, so you can see how it works. I will connect to the drone via Wi-Fi. with a wireless connection. So I have one machine, I am at home, I use for work a gaming PC that I have, and my PC is connected wireless to I have a Velop mesh network here, so I'm connected via a network cable to my network. So I have these two connections up and running. I'm hoping for the best, that everything is going to work. If somehow I lost connection because demo times and these things happens, I have a couple of videos to show how everything will work, but it usually works fine, and this is what I am going to do. So the first thing is, let me show you how I can connect to the drone. So I have my drone here. Let me show you the drone. As you see, it's a toy. It's literally a toy. It's very small. It's my hand size. It's a toy. And when I turn this on, I will press the button, and there's going to be a LED blinking somewhere there after a couple of seconds, so it's on. What I am going to see is that I will have a new network available in my network at home. You can see that I have my home network, I'm Ironman, and then I have the drone one, which is Telo, and kind of a serial number. So I can connect to the drone directly from here. I don't do this. I don't connect to the drone using the wireless. What I usually do is, let me go here to my Windows terminal, and what I have here is I use a command, which is basically a net command, which I'm going to say net connect to the drone. And in order to see if I am connected, I am going to open a ping network. So you can see there that I am connected to the drone. So this is something that we are going to see a lot during this demo. Basically myself going up and back and forward with the connection, because sometimes the drone gets disconnected. Remember, this is a toy. This is not a professional drone. This is just a toy. So if I get disconnected, I need to turn the drone again. I need to connect, and I will use the ping window to validate that I am really connected to the drone. So that's kind of a disclaimer of, hey, you're going to see a lot of command windows today. This is why. And let's move forward to see how we can do this, how we can start to interact with the drone. So I know that we need to use sockets, that I need to open UDP connection, I need to send these commands. So the way that I set up everything here, in my head, when I started to write this, I decided, okay, I am going to create two main lines of communication. One, to send actions, and the other to receive actions. In this case, are commands. I am going to send commands to the drone, and I'm going to receive commands from the drone. And the first thing that I'm going to do, I am going to send a command, which is command. It's literally the string command, which basically said to the drone, hey, we are starting in the debug mode. We are starting the SDK mode. And then I'm going to read the battery to see how much battery do we have in the drone. So let's do this. Let's see how we are going to do. In a nice word, in an official word, what we are probably going to do is make the drone fly and these kind of things. Not today. If I make the drone fly right now and I broke it, I don't have any more material for the talk, so I will fly the drone at the end of the talk. But let's start with this. So let me go to, here it is, Visual Studio Code. I will create a new file, demo.py, and let's start to write some code. Let me make this a little bigger. So I will use, as I said, I will use three main libraries: sockets, threadings. I will open the socket, each socket in a different thread, and I will use time, and so that's my import. Then I will write a couple of receive functions. And the receive functions are very, very simple. I have the receive data, I send information to the drone, and I want to have the response, and I have the read state. This is another socket all the time giving me information about the drone. So in each one of these, I have a client socket receiving information, and this other is a state socket receiving information, and of course, a while true to see what we can do. So once I have this, my next step will be, okay, let's send information to the drone. And what I am going to do, very simple set of lines. I am going to send the command here, and the command is going to, I will have a timestamp. I will send the command to the drone. I will check the response. The response is the one that I have here in the top, in the other one, to see basically if I have error of OK. And once I have the response, I will basically check for a 5 seconds timeout to see if it's working or not, and I will return this. So it's a very simple, let's send information, and I have a couple of overrides here to send the response. And by the way, the command that I sent, I need to encode this in UTF-8. I learned this in the hard way, but that's basically it. It's not more complicated than that. So I have my two main lines to read states, read information, and send information to the drone. My next step will be, okay, let's connect to the drone. And as I said, I can connect to the drone. I know the IP. I know the port. I have this document where I explain the port. So what I am going to say, what I am going to define here is two sockets, one to send information, another to read the state of the drone. And I am going to open the two sockets against this IP with the two ports. It's nothing very complicated. And then I am going to start these functions in different threads, in daemon mode. So I want them running all the time in a different thread in the back. So it's kind of easy to do. And then this is basically my app. Once I have my setup, everything from line 92 to the beginning is something that I can encapsulate. And this is my app. I will read the battery. So I have here a battery, an integer. I will start the drone with the command information. So I said, okay, let's start the SDK mode, and then let's read the battery value. I will wait some time because I need to basically wait to see everything that's happening, and I will print the battery value of the drone. So this is it. Let me go here, copy the location of this file, and let's run this. So I'm still connected, that's fine. I don't need this one. Let me open a new one. I have a couple of Anaconda. And by the way, I am using a couple of libraries here, so I am going to explain later what do you need to work like this. But I am here, this is our file, demo.python, created 5 seconds ago. So let's run this. Oh, I just get disconnected from the drone in the top. So I will go here, turn again the drone. The drone is on, and now it's blinking. So what I am going to do here is I am going to connect again to the drone. My Python file. So nothing fancy here. This is just going to connect to the drone, read the battery, and I know that the battery right now is 91%. So this is probably the most boring demo ever. You just write the number 91 from the drone. Sorry about that, but let me show you a cool thing that we can do here. So I will increase here the time of sleep to 30 seconds. And every time that I read information from the drone, I am going to show this in a list here. Then let me show you the list of the info that I have. So this is what I have. And you can take a look that here, I know that the battery is the item 21 in the information that I get from the drone. So when I have this, I'm still connected. I am going to run again the demo file, and this is what is going to happen. It's going to show me a lot of information, but if I start to move the drone, you can see how the information is changing because the third or four first parameters are basically the rotation, inclination, and movement sensor of the drone. So I am getting real-time information from the drone. And if you take a look here, let me do a couple of zooms here. I have the pitch, the roll, and the yaw, which is basically the axis of the drone. I have also the axis for the Y, theta, and X. I have the temperature. I always forget which is the difference between temp L and temp H. But it's the temperature of the drone, 96 degrees. It's kind of hot right now. The time of flight, I have the height, the altitude. I have the battery values, 90%, the barometers. I have a lot of information. So I am reading information from the drone in real time here. If I want the drone to fly, I will just need to come here and say, hey, command, and then take off. I can do a sleep of, I don't know, 2 seconds and do a land. So with these lines of code, I can connect to the drone. Making takeoff, it will fly, wait a couple of seconds, and it will land. I will do this later. Again, I don't want to fly the drone, hit it into the wall. That stuff happened and stop the demo, but it's very easy. I just created a couple of lines to connect to the drone, to read information, to send commands, and I can start to work there with this. So it's very, very easy to see how we can use the drone. So let me move forward with the story here. So the third port that we have in the drone is the one for the camera. And this one, again, is a UDP port. It's in the port 11,111. And when I read the documentation and I found this, I started to play around to see how I can connect to the drone. The first thing that I tried to do is try to connect to the drone with BLC. Didn't work. Weird, because BLC basically work with almost everything. So then I start to try to use a couple of tools that I found in FF and PEG. It was fine, but they had a lot of delay. But then I remember, I've been doing a lot of OpenCV stuff. I know OpenCV. I did a lot of OpenCV in C++. I'm also doing a lot of OpenCV right now in Python. So I would say, hey, why not make it in OpenCV? Maybe OpenCV works. And it's really, really, really easy to do. So let me create a new file here. Let's call this one camera.py. PI, and let's start with the OpenCV demo for the camera. So first line are the same lines that we already have. The only difference here is that I am going to use OpenCV. So I am importing OpenCV. I have OpenCV installed here. If I go to my console, and I check OpenCV and I do cv2.version. I installed OpenCV, the version is 4.2.0, so it's kind of nice. OpenCV version, I have in this environment, I have OpenCV, and are the same lines to connect, to send information, to retrieve information. Everything is the same, but let's also connect to the camera right now. So the first thing that I'm going to do is I am going to send to the drone the first command to start the SDK mode, and then I am going to send another command to start the streaming of the camera. So I will say stream on. This is very important. If you don't send this command, the camera will never start streaming the frames. Once I have this, and this is the magic, I will basically define the address of the drone with the port. I know the IP, I know the port, so I define the address, and I will open a video capture element in OpenCV. And this is the same line that I use if I want to use my camera. If I want to open my camera, I will say, hey, video capture item 0. Item 0 is my first camera in my machine, so that's it. But here, I will use the address, and that's it. It's going to start to work. I will give a couple of moments, a couple of seconds to basically make the connection, and then I can start to make the OpenCV app. And the OpenCV app is a very simple one. What I am going to do here is I am going to check the battery all the time just to have kind of a live connection to the drone. And then in a while true, I am going to check the battery and print the battery value. And then I'm going to read a frame from the drone, resize the frame, and show it here. So let us show it. And to show that this is the demo, let's change this for global AI talk. And then if I press the Q, the letter Q, I will stop the program. And another thing that I learned in the bad way is that at the end, when I stop the drone, I need to send the command stream off. If I don't do this, the drone will get basically in a crappy mode. I need to take out the battery, wait a couple of seconds, and start again. But this is the camera demo, so let's run this. And let's clean this. Here I should have my camera file. There it is. My drone is disconnected, so I will connect again to the drone. So let's go here. Let's turn on the drone. The drone is turning on, and let's connect. It will take some seconds. Not there, one more time. There it is, it's connected. So I am going to run the camera demo. And the camera demo is basically, you can see a couple of commands, events sent to the drone there. It's sending information, opening the UDP, and there it is. This is the camera feed. I am moving my drone right now, and you can take a look at the response. It's very, very good in terms of how it's working. The frames are kind of fine. I will show the amazing Sammy there hosting saying hi. So it's kind of working nice. It's kind of nice to have. And again, it's all part of, I only need to add a couple of lines here to connect to the drone, to open a UDP port using CV2, using OpenCV, I'm sorry, and then pick up the frame and show the frame, pick up the frame and show the frame. Someone asked me in one of these topics, in one of these sessions, how fast does this work? And this is the same line of code. The main difference here is I am going to show the frames per second. So I have here kind of a timestamp, and after I read the frame, I will make some calculations here to see the timestamp, the initial time versus the current time, and by one. So when I have this, I will show the frame per second. And if I'm still connected, which it seems that I am still connected, this is the same demo showing the frames per second, and usually goes up to 30, and depending the day, because I have a lot of wireless here, today I'm over, let me try to point something with color. So you see here that it go for 30, 40, 50, 60, 70. If I don't move the drone, it go to 100. So 30 frames per second is a very, very good number. It's something that we can work. It's something that I can start to play around and make things with this. So once I have here, and again, this is all code that can be easily encapsulated in an SDK. Once I have here, it's all about, okay, I have access to the drone information. I can send information to the drone. So the next step is what I can do. What else I can do? So the first thing that you want to do, or one of the first thing that you can easily do with OpenCV is do face detection. There's a full story here, and this slide and this joke is very, 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 very old. But basically, I start to play around with cameras and images. I make a lot of OpenCV, and I make a lot of tests trying to do face detection, object detection, facial feature. I even get to the point to tweak everything to do these facial features. That's my little daughter. She's the one helping me to test everything here. So you can do a lot of things, but to do face detection here, one of the easiest way to do this is to use the Viola Jones algorithm, which is almost 20 years old. But the cool things about this, and I am not going too deep to explain how this works, there is a lot of info around how this works, is that it's almost part of OpenCV. It's almost part of the stuff that you can go. You can go to the OpenCV main repo in GitHub and take a look at all of these hard cascades definitions that are there, basically created to allows you to do face recognition. And the way that this works is these hard cascades are definition of elements. Let me show you how this works, that you can embed in your code, and you can start to do face definition. So let's do this. Let me create a new file here. Let's call this one face.py. There it is. This is my file. Let's go for the 40. So everything, as we see, couple of commands, couple of functions to send information and receive information, sockets to make the communications, threads to run these sockets, and I have here the OpenCV to connect to the camera. I have everything, but I am going to create a demo to recognize files. So the first thing that I'm going to do here is basically read using OpenCV the hair cascade file. And this is the hair cascade. Let me pick up one. I need to copy this, the frontal face. This is the hair cascade. It's a big XML file, which is basically going to analyze the picture. I need to convert the picture to a grayscale picture, and it's going to analyze the picture, and it's going to find some patterns, and it's going to do some math to see good or bad. And this good is up, is bigger than our threshold. It's going to see, hey, there's a face there. So what I'm going to do is I'm not going to go deep here. I am going to just paste this file here in the same folder of the demos. And in OpenCV, what we are going to create, we are going to create a cascade classifier. So this is a simple one to recognize faces. We have other to recognize eyes, bananas, and you can create your own. They are not very, very good. There are better ways to do this, but this is a very simple one to start. So once I have this, let's go to my app. And the app is the same app. I will have a while true loop. I will connect to the drone and get the frame. And once I have the frame, this is the important lines. I am going to convert the frame to a grayscale picture because OpenCV and cascades use grayscales here. And then I am going to use the face cascade to detect faces. If I have a face, I will have an array here, and this array will have 4 elements, basically the coordinates of the frame, the top and right, and the bottom and left. So I know where is the frame located, and I will draw here a rectangle in my camera view in the OpenCV, and I will show this as the OpenCV. So let's go here with global AI faces. So that's basically it. As part of my while true, I will send the command. I will read the battery and show the battery. But that's basically it. I have everything ready here to start to show how we can recognize faces. So once I have this, I need to go back here. Let's clear this. Let's find the faces. Everything is here. I just paste everything. So let's do a Python face. But before going there, let me turn on the drone again. This is the tricky part, and connect to the drone. I need to do this every 5 minutes. It gets disconnected. This is the moment that I can drink some water. It's connecting one more time. There it is, connected. So let's start this one. So it's going to connect to the drone, open the camera, start to show everything here, start to show the faces. And here, see it's moving. If I point it to my face, somewhere here, you will see that I have the frame here. So somewhere here, you see the red frame. It's kind of working. It's kind of nice. Let me take this to a different level. So I like to show this using the amazing video that we have in the Global AI Community Tour, where we have a set of TVs with the faces everywhere. So I will put my video somewhere here. I will mute this. You can see a lot of familiar faces there. Seth is there, Hank, Sammy, you are there also. Everybody's kind of here. But let me show you the drone. Let's point it to the faces. And let's run the video. So I hope the streaming is good enough that you can see a couple of faces detected from there to there. You also see that I have some kind of camera interference. I have a couple of not very good wireless signal here. I am inside of my home. There is a lot of stuff happening here, but you can see a lot of faces recognized there, and it works great. I mean, I can do this, and again, it's only 2 lines of code. It's only requiring me to detect face, initialize this, and do something else. It's not much more complicated than that. So this is the moment where I created other demos. Let me stop this one and start to show you other demos. Where in example, I create one. I have one here who basically recognizes faces. I train a model to recognize faces, and if the faces are using or not a face mask, because we live in these pandemic days. So hey, let's try to do something funny. So I have one demo here. It's not as part of this demo, it's part of other demos, but I can go here and let me show you how, and also recognize if the people are using face mask or not. So let's go back to my events. I will open a new terminal and I will run my demo number 10. Let me double check if I'm still connected. Yes. So, oops. Oh my God, I opened this demo with I opened this demo with another editor, and I think I killed I broke my tabs. So let me just open this in code and save it again. It will be open soon. Let's see where it is. A couple of seconds, it's not here. One more time, this is what's happening. Real demo. Oh, I have some issues somewhere there. No problem. I can fix it later. Basically, what I have here is an extra tab at the end. I didn't suppose to open this with another editor. I can use it later. But I have these demos using the drone, analyzing something different. And one of the demos that I also wanted to do is, hey, you know what? I want to fly the drone, and I want to make the drone detect something else. So, in example, I created a custom vision, and I know that we talk about this a lot, so I am not going to go deep here, but I created a custom vision, a custom vision project, taking a lot of photos of my MVP walls to basically make the drones identify these MVPs awards. So I have these pictures where I train the model, I select my own MVP elements, and I have a vertical picture, horizontal pictures, and whatever. And what I have here is one row, two rows, a couple of different. And I train this model. I have kind of a decent training once I play a while with the pictures. And by the way, you can see also that I trained this using photos from my previous wall, a different color before I paint the wall. And when I train this and I have this, I can use and train this and make some tests using the live version from the model that I trained. So I can go here and select, I don't know, let's select this one. It will take some time, and it will recognize my MVP walls. They are almost there, all of them. And what I like to do here is I exported the model to be run also locally, because I want to use this locally. So I exported this to be used as a Docker file in Linux. So I have locally, let me start Docker. So I have here a Docker instance running this model. So I can test this also I can use this locally using Docker to start to play around with this. And the idea is that Docker is starting. The idea is that let's also start Postman. Once I have my Docker container up and running, I can start to basically do the same analysis, try to find my MVP frames locally just using this. So let's go back here. Let's minimize a couple of things, and let's start a test here. So what I'm going to do, let me clear this. Let me show, this is the images that I have here in my machine. One of the images that I have is the MVP award detector. I make a couple of versions, now in version 1.1. And what I am going to do, I can run this container. And once I have this container up and running, if I go here to Docker container ls, let's show everything. You will see here that I just started this container 8 seconds ago. It's been up and running, and it's in the port 8070. So of course I can do the same from here. I can take a look at my stuff here. But what I can do right now is I can make some local post to this URL locally to analyze if I find an MVP poster. So let's create one. Let's select a file. Let's select a one, I don't know, let's use one for test. This one, I will send this locally. And while I'm sending the request, this is the output. As you can see, I am doing this locally with my Docker container here, all exported from Custom Vision. And what I have here is basically the output. So it's detect one MVP with a 96% of probability, which is very good. And this is the location of the frame. This is the bounding box. So I have this locally. I can train this with 1, with 2, with 4. It's basically the same output that I have here in my predictions. So I think this is it. I have this is the same that I have here, 96.3 in the web. I have 19c.5 somewhere, somehow here. So this is what I have. So right now, this is the moment that I decided, okay, let's create a demo where I will fly the drone around. I will connect to the camera, and the camera will analyze in real time if it detects or not MVP's poster. So in order to do this, what I can do, what I write, and this is the full line of code, I'm going to review this, showing this how it works, is I have the same lines of code using everything, but when I, let me do something else. When I read the frame, I will enable and disable the detection just to show in real time how it works. I will save the images to disk so I can show you in real time what I am detecting. And then I am going to make a post request to the local Docker container to analyze if I found an MVP award. And if I found an MVP award, I am going to show the displays here. And show the displays is basically a display prediction is going to do a couple of things. It seems that a lot of code, but what it's basically doing is I am reading the JSON objects here, the JSON response, I'm sorry, and I'm sorting the prediction based on probability. Remember that one of the values that we have here is probability. And when I have the probability, I am going to basically, if the probability is bigger than a threshold that I have defined in 50 here, I am going to do some math to find where is the bounding box. Remember, the values that I have here are not the exact location of the bounding box, but based on the analyzed frame, this is the location at 14% or 60% or 62%. So I will use some math here to basically find the location of the bounding box. I will draw the bounding box and I will print this into the box, into the console. So we know that something is detected. And then I am going to save this file to the disk so you can take a look how this works. So that's basically it. And I have a couple of other stuff here, but basically to support the demo. So let's run this. Let's run this in real time. This is the number 66. So I will go back to my commands. Let's minimize all of this. Go back here. Go my event. And my drone is turned off, so I need to turn on the drone again, and I need to connect to the drone. There it is. It's almost there. There it is. And now I am running, oops, not this one, this one. Let's run the Python 66, the drone camera Docker MVP complete. So it's going to do everything that we just see. It's going to connect, it's going to open the camera, connecting using OpenCV, and it's going to start to show the camera. You can see also the frame upstairs. This is in the top left corner up. It is 40 and bigger number frame per second. So I'm going to start to move the drone around my office. This is my MVP wall. There it is. And what I am going to do here right now, if I press the letter D, it's going to start the detection. So when I start the detection, of course, it's going to have a lower frame rate. And what is going to happen is from time to time, it's starting to detect, you can see there how it's starting to detect frames there. So that's really the drone detecting stuff, detecting frames using a local container to do this. There are other ways to do this, more amazing, but let me show you what it's doing right now. So let's review this for a while. Each one of these values that we can see in the terminal is the output when someone is detected from the Docker console that we have right now. So we find something here with the probability of 70%, another one with the probability of 13%. So this is the frame that is going to be shown. And what I am also doing here, I am saving all of the frames that are recorded by the drone. So this is all of the images recorded by the drone. I have everything here. And I'm also saving all of the ones that have been detected. So all of these are the ones that have been detected. So you can take a look here how it's almost fine. It's almost accurate. In this one, we have plenty of ways to do this. It's kind of fun in terms of what we can do and how we can make it work all together. So this is the stuff that you can do. You can do stuff like, hey, make the drone fly, and when the drone is flying, recognize a face or recognize this. You can save all of this info. And again, it's not complicated. It's basically just picking up a camera and doing this. For the next big demo that I'm preparing right now with the drone, I want to use Project Bonsai to basically stabilize, create a brain to automatically stabilize a drone, because I know the values and I can train a brain to help me stabilize the drone. And let me show you as kind of the final demo, the final one. We talk about, let's use AI, let's train the drone, let's see what we can do. So one of the demos that I have here is basically the same demo, the same code that we're seeing right now, with the main difference is that I'm going to detect faces, and when the drone detects a face, it's going to make a flip. So the drone is going to start to fly, and when the drone is flying, if the face is detected, it's going to make a flip. And the way to do this is basically I will send the message to make a flip. And because I don't want the drone flying all the time, I will capture the keys T and L to basically make the drone take off and land. So in the back camera, you're going to see the drone displaying information, and when we have this up and running, it's going to fly. So this is the 50. Let me see if I'm still connected. All of the things that we know about connecting to the drone. And here, Python 50, 22 on the drone this direction. And the drone is going to start on the it's connected there. There it is. So the drone is in the down there. I will press T a couple of times to make it fly. Oh, started to fly and went directly to the wall. And I lost the propeller. Where is my propeller? Okay, so this is what happened with the live demos of the drone flying. You can see there that I'm missing one of the propeller, this one here. Let me take off my, this is the live demos that I do, sorry about that. But hey, the drone is still connected, and this is what you have. I don't know if we want to start with the Q&A. I need to build basically the drone again. While I am fixing this, I don't know where it went. It will be easy if I find it, but I don't know where it is. So I am fixing this, not this one. There are two type of propeller here, so I need to find the right one. There it is. This is it. This is the one.
This happens often, Bruno, that you fly it against the wall.
Yes, and it's maybe because my kids have been using the drone. I haven't tested yet today. I haven't prepared the drone, and usually what I need to do when the kids are use the drone, I need to spend 5 minutes stabilizing the drone again, because they hit it so well with everything, so the drone doesn't fly straight. It goes like this, but hey, this is part of having fun. Again, this is a toy. This is literally a toy, but you can do a lot of very, very good things. Imagine that you can use this to fly in a supermarket or in a warehouse, in an aisle, analyzing the products, reading, scanning barcodes, or these kind of things. Again, we are doing this with more professional drones, but this is a nice starting point, because $100, maybe more, maybe less, is not very expensive to start. So yes, it's happened a lot to fly directly to the wall.
it's perfect to build proof of concepts. Huh? It's just something small and cheap, but you can try everything before you pay for the real deal.
That's kind of the idea, to basically start to see. And also, I am going to be completely honest. For me, it was the chance to start to learn. I use a lot of Python to do machine learning stuff. So I know a lot of pandas and datas and work with vectors and matrices and tensors, amazing. But I never do multi-threading. So, hey, this is maybe the chance to learn to do some multi-threading. Sockets, I never play with sockets. So it was an excuse for me to learn all of these other I don't know, features, knowledge, or points that you have probably from other languages, also in Python, and it's a nice project. It's nice something to validate ideas, to learn something new, and also to have fun.
For sure. You still want to share something, Bruno?
No.
Okay.
I have a couple of slides at the end, and I'm going to show this, which basically have a lot of resources. I am going to share everything, including the code and a live video of this working. Sorry about that.
No problem. It didn't happen. But we all know now what you wanted to build, and what I was wondering, because now you showed us everything like in a good 50 minutes and less. How long did it actually take you to build everything and figure out how everything works?
So the first time that I did this demo was for the similar one was for the global AI in April, I think. And it took me a couple of months to basically get there, to connect to the drone, to understand how it works. So spending a couple of hours every day or a couple of days, in a couple of months, I managed to understand how to build it. From there to now, it was all about how I make it work faster, how we can improve the image recognition. So it's very easy. Sadly, there is no official SDK for this model. You have other models, more expensive, who has SDK. For this one, you don't have an official one. But if you like artificial intelligence and you like the computer vision, this is basically another data source that you can use to analyze pictures and to recognize objects, whatever you want. But it's a moving drone, so you have this moving capability also. It's not just static camera. So in a couple of weeks, you can get up and running. And from there to today, it's all about imagination. What else you want to do?
It was, I think it was in 2018 during Build that Microsoft announced the collaboration with DJI, that they released what was still a preview version then of the SDK to connect to I think it was DJI Spark.
Yes, it was one of the big ones. Not the big one, the professional ones. One of the
professional ones. But even those ones, you couldn't run like AI models on the device. You still had to stream your video feeds to a computer to do some kind of edge computing closer to the device than just on the device itself. So that was really
that's another very good point. Depending on where you live, I know that there are some places that in order to fly those drones, the big ones, you need a license, kind of a driver license, but you need a drone flight pilot or something like this license. This is still a toy, so this is still in the limit that you can play with this. And yes, you need to do that. But I am guessing that, as you said, that today we are going to start to see some drones that are going to have some capabilities inside the drone, so we can export these models and run everything in the drone, which is going to be amazing. But still, this is the place that you're going to start to learn how to do this. And then you can move to a bigger one that you can run everything there, your image models, your navigation path model or whatever. Hey, that's a nice challenge, expensive challenge also.
True. Let me see if anyone has questions for you. Not at the moment. So if people still have questions, you can always ask questions to Bruno live right now on YouTube chat. If you have questions for him later on, you can always go, send him a Twitter message to @lbruno. So I guess that's it. Also next week, we will have another speaker. We will have Sebastiano Galazzo. He's an MVP from Italy, and he will give us an overview of how to get started with Microsoft Azure Machine Learning Studio. He will give us some basic understanding of generative deep learning algorithms, focusing on autoencoders, and will show his journey from the beginning, his mistakes and tips that he learned among all the things he built. And the main idea is to generate photorealistic avatars. So also very, very interesting topic. That's next week. Don't forget, if you are a speaker and you want to share an interesting topic with everyone, well, we also have our Global AI on virtual tour in October. We're still looking for extra speakers. And if you go to live.globalai.community, you can register for the event. You can already submit your own sessions also. And everyone is welcome. Share the news so we can share this awesome topics with everyone in the world. And again, it will be a full day of more than 24 hours stream with different hosts and many different speakers. So Bruno, I want to thank you for your last minute joining us for the Global AI Global AI Talks live. Well, for you, it's still a whole day to go. So enjoy the rest of your day. And for all the ones who are watching this episode right now, well, have a good evening, a good of the day, and we hope to see you soon again. Thank you very much for joining.
Bye. Thanks.